Hello students, welcome to this next lecture. In this lecture, we will discuss about different lathe operations. So let us start with our first topic, that is the lathe operations. So on the lathe machines, there are many different number of operations that can be performed very easily. And what are the meaning of that different operation and where that different operations will be helpful, that we will discuss. So starting with our first one, that is the straight turning operation. So first of all, let us understand what is the meaning of turning. So turning is just a simple operation in which workpiece is rotating and the tool is fed towards the workpiece and the material removal takes place. So in this particular case, there are mainly two to three different types of turning operation. From that, the first one is the straight turning operation. Now the straight turning operation is helpful when the diameter of the workpiece is to be reduced. That means straight turning operation is helpful when diameter of the component needs to be reduced. And for that, when the workpiece is rotating, then this tool is given movement in first workpiece direction, and after that this tool is fed in the longitudinal direction up to which the diameter needs to be reduced. That means the diameter can be reduced over entire length also and up to the certain length also. So in simple words, again, this straight turning operation is helpful when the diameter of the workpiece needs to be reduced. Now the second one, that is the taper turning operation. And as we have discussed in our previous lecture, whenever in any of the component a gradual reduction in the width or thickness direction or in the width or thickness along the length of the component is required, at that time taper turning operation is required. So this taper turning operation is helpful to generate taper on any of the component. Now the third one, that is the facing operation. Now this facing is nothing but the turning operation, but this facing operation is required when length of the workpiece is to be reduced. That means this facing operation is required when length of the component needs to be reduced. So in this also a simple workpiece is rotating and this tool is fed towards the workpiece to remove or to reduce the length of the component, and this operation is also done in step by step manner as the depth of cut cannot be given in larger amount. So in all these three operations, the first one is the straight turning operation, then second one is the taper turning operation, and the third one is the face turning or facing operation. In all these three methods or these three operations, single point cutting tool is used. Now the fourth operation, that is the external grooving operation, or simply you can see it as the grooving operation. Now grooving operation is nothing but simple. From figure you can see that whenever in the workpiece or the component a reduction in diameter is required up to certain location or up to certain length, at that time the machining operations to be performed is called as the grooving operation. And in this particular operation, the diameter of the workpiece reduced is comparatively lower, and also the length up to which this diameter needs to be reduced, that is larger than the width of the cutting tool. Here you can see that the cutting tool has a different design and it has the wider cutting section. So this type of the larger width cutting tool is used for the external grooving operation. And again, this grooving operation is helpful when one way to reduce a diameter of the component at any certain location and up to a certain length. Now the next one, that is the profiling operation. So this profiling is nothing but whenever on any of the component, a certain profile needs to be generated. At that time, that cutting tool has given also the movement and that profile direction. So the movement in particular profile direction is helpful to generate that profile on the workpiece, and that type of operation is called as the profiling operation. As you can see in the figure, in this figure, this workpiece needs to be moved in longitudinal direction also, in perpendicular direction also, and it is also needs to be given a movement in the angular direction. So the combination of all these three movement helps us to generate the profile on the component, as you can see on this particular workpiece. Now the next one, that is the face grooving operation. So this face grooving operation is similar to that of the external grooving operation, but in this particular grooving operation, the entire operation is done on the face of the workpiece, whereas in the external grooving, the operation is performed on the external surface or outer periphery of the component. So here similarly you can see that this cutting tool is moved towards the workpiece, or you can say that along the length direction on the face of the component, and this is helpful to generate the grooves on the face of the component. So external grooving and face grooving are almost similar, but these are performed at different location on the workpiece. Now the another lathe operations are the next one, that is the cutting with a form tool. That means whatever the design or the cutting shape is required on the workpiece, that similar type of opposite shape is generated on the cutting tool, and this cutting tool is fed towards the workpiece, and as workpiece is rotating, this cutting tool generates the similar shape as that of available on the cutting tool. So this cutting tool has the shape that is required on the workpiece, and that's why this tool is called as the form tool, and the operation performed using this form tool is called as the cutting with a form tool operation. Now the next one, that is the boring operation. So the boring operation is, in another words, you can say that it is the operation which helps us to enlarge the diameter or the already existing diameter in the component. Or in another word, boring is the operation with which one can enlarge the already existing hole in the component. So you can see from this figure also, and if we say now, if first available hole is having diameter d, but now we want to enlarge that hole up to the capital diameter D, then what happens? The cutting tool this boring cutting tool is available in this particular shape, and at one end the cutting tool is available which is rotating about its axis. So the rotation of which helps us to enlarge the already available hole, and this tool is fed in downward direction so that the entire already existing holes can be enlarged very easily. So this is the boring operation, and similarly using that tool internal grooving can also be done. Now grooving can be understood very easily, as we have discussed what is the external grooving and the face grooving. Now the next one, that is the cutting off, or this operation is also called as parting off operation. So this operation is helpful to generate a part on the workpiece, or also to cut the component from any particular length. This parting off operation is also helpful. But in this particular operation, it is important to understand that the length which is reduced using this parting off operation is similar to that of the length or width available of the particular cutting tool. So this cutting tool width is similar to that of the parting off width, And if the parting of width is larger than the available cutting tool width, then that operation is called as the grooving operation. So this parting off is helpful to generate a part on the workpiece or to cut off that part from that particular location. Then this operation is also called as the cutting off operation. Now the next one, that is the threading operation. The operation with which thread can be cut on the component, that operation is called as the threading operation. The next one, that is the drilling operation. So the operation with which hole can be generated on the workpiece, that operation is called as the drilling operation. And for the drilling operation, this drill tool is set on the tailstock spindle, and here during the lathe operation this workpiece is rotating, and this drill tool which is fixed on the tailstock is moved towards the rotating workpiece, and after providing feed one can generate the hole in that particular workpiece. Now the next one and the last one, that is the knurling operation. So the knurling is the operation with which on any of the component diamond type grooving structure can be generated. That means grip like structure can be generated on the workpiece using the knurling tool. So the knurling design that is generated using this null tool is like this diamond type structure. So this type of structure on the surface can be generated using this knurling operation. So in this knurling operation, as the workpiece is rotating and the knurling tool is also rotating inside this particular fixture, so the rotation of both is helpful for particular knurling operation. And in this RPM of the workpiece is very slow because both the components are rotating in opposite direction. So up to now we have discussed about the different lathe operation which can be performed easily on lathe machines. So I hope you got the clarity about all these topics. So looking forward to see you all in our next lecture. Up to then, thank you.